Hi, everyone. Welcome to Building the Future, Dataverse for Intelligent Agentic Apps and Agents. Today, we'll focus on innovating and getting the most value out of your business and operational data in the era of AI with Dataverse. My name is Julie Koesmarno.
I'm Sean Watson, and we're from the Microsoft Dataverse team.
In this session, we'll begin with an overview of data in the era of AI, what it means for your applications and agents. Then we'll translate these more concretely in the Dataverse intelligent agentic apps and intelligent agent scenarios. The last decade was built on a data and AI foundation. Dataverse has been with you, millions of low-code makers and pro-code developers, to build solutions on top of systems of record. Together with Power Platform, Dataverse has been the enterprise solution to unify common data for your apps and to store operational data for your business applications. Today and in the next decade, Dataverse will continue empowering AI organizations to transform business processes using Copilot and agents. With Dataverse, you can easily apply generative AI to your existing data and store operational and business data for your agents alongside your apps. Customers rely on Dataverse as their enterprise-ready, trusted data platform for intelligent apps and agents today. Dataverse is built on top of Azure services to help you scale and bring intelligence to your data with generative AI. In AI-first organizations, certain patterns are becoming increasingly evident. Today, we'll explore two of these patterns. The first pattern, which has been prevalent over the past couple of years, involves human assistance with Copilot technology. This year, we anticipate the second pattern to gain traction. Teams of autonomous agents and humans working together, leading the way for AI-first organizations. We'll spend the rest of the sessions diving deep into these two patterns, focusing on Dataverse for intelligent agentic apps and Dataverse for intelligent agent scenarios. Building intelligent agentic apps with Dataverse and Power Apps showcases the human-assisted with Copilot pattern. You'll see this pattern in 3 out of the many powerful features to boost your productivity, either as makers or end users. Plan Designer, Prompt Column, and Data Exploration Agent. Now let's check out Plan Designer. Plan Designer, announced in November last year, is now GA and includes Data Model. Data Model agent in Plan Designer helps to convert user requirements to Data Model in your Dataverse environment. You can also view an entity relationship diagram and chat with the data agent to modify the data model, giving that seamless blend of agent-assisted and graphical user interface approaches. Here I have a short data dictionary that I'll use to upload to the Plan Designer. Using Plan Designer, let's build a product review solution for a retail company based on the data dictionary. The Plan Designer agent's getting to work and drafting user requirements, stating the personas and jobs to be done. It's such a great companion to makers. Then the data agent is at work proposing a data model of 6 tables. Now let's visualize these tables. And I'm seeing that we could potentially reduce the number of tables here. So let's go back out to the Plan Designer. And from here, I can ask the data agent to simplify these tables. The class, division, and department tables can be consolidated into the clothing review table. Okay, it looks like the data agent understands what I want now. And let's visualize this data model again. The cool thing about this is that I can now visualize and also use the UI to interact with this data model. It looks pretty good. And I'm happy with this. So let's continue with the rest of the Plan Designer to create the apps and so on. Amazing. If you have used the formula column in Dataverse previously, you're even going to love this more. Prompt Column helps you to apply generative AI on top of your data in Dataverse. It helps you build business logic using prompt. Let's check it out. In this product review table, I have a column called review text, which I would use in my prompt columns. Creating a new prompt column is easy. Let's create a new column, then choose the prompt data type. This add new prompt loads the prompt editor. Now, for the purpose of this demo, let me show you the two prompt columns that I have created earlier. The sentiment column is a prompt column, so let's take a look at that. This prompt editor allows you to refer to other Dataverse columns, and you can also test it too. The knowledge is a good debugging tool that you can use as you evaluating your prompts. Now let's take a look at the redacted PII review text column here, where we want to obfuscate any of the sensitive info like brand name or personal information. Again, using the prompt editor here, I can refer to other Dataverse table. Now, let's see how this prompt column works in action in an app. All right, here I'm just going to change a few. Here I'm just going to change the text, and let's save, and we should see the resulting redacted PII review text and sentiment updated. The last two features have covered how generative AI has helped makers. Now let's check out how it helps end users too. Business users can simply describe the filter they want and visualize their data with Data Exploration Agent. Let's take a look. When enabled, my model-driven app has this Data Exploration Agent search bar where I can start typing filter conditions. The grid will soon display the data that meets those filter conditions, and the filter tags are also updated to reflect them too. And I can continue adding and modifying the filter conditions. Great, looks like the grid shows the data based on my filter, so now I can visualize this. And it's just as simple as that. You can think of agent complexity as a spectrum. On the simpler end, knowledge retrieval agents. AI agents, particularly those built with Copilot Studio, can natively access enterprise data stored in Dataverse. This allows agents to retrieve information, to answer user questions, provide context, and ground their responses in reliable business data. This is facilitated by features like Dataverse AI ML Search, enabling end users to ask natural language questions about Dataverse data and receive answers from agents. Next, task agents. Beyond retrieval, AI agents can leverage Dataverse connectors available within the Power Platform ecosystem to perform actions on the data. This allows agents to automate workflows, update records, and integrate with business processes that rely on Dataverse. And finally, autonomous agents. These advanced agents can operate independently, plan dynamically, orchestrate other agents, learn and escalate issues. They can work with your business data in Dataverse. Their operational data and outputs can be easily stored in Dataverse. The three key features that illustrate building a team of agents across this spectrum are Dataverse knowledge, which leverages RAG, reusable functions in Dataverse, storing your agent's operational data together with your business data in Dataverse. Now I'm going to hand over to Sean to show us how knowledge and functions work.
Thanks, Julie. As you've already seen, Dataverse is there to support your agentic data needs. Another way that we also support your agentic data needs is through Copilot enabling any data in Dataverse in under 5 minutes. To do this, we transform your business data into knowledge, high-quality knowledge, knowledge which is reliable, relevant, and something that can be leveraged and reasoned over by your agents. As we talk about Dataverse data, there's two common types of data. There's the unstructured, think of your files, your multi-line text, and your structured data. Think of your relational tables. Let's take a look at how we transform that data into knowledge, starting with files. As a maker, you're probably already very familiar with uploading knowledge directly to your agent, static content. As those files are uploaded, they trigger a process for indexing. We as Dataverse will download those files, process those files, analyze the content, determining optimally how to extract the information from the data that is being provided. For example, we have bespoke approaches depending on the type of data in that file. Let's take a PDF. A PDF may contain text, images, and even embedded tables. Each of those are going to have a different approach. Once that file has been processed, we'll paginate all of that extracted text, chunk it up, start the index approach. Here we'll index for both text and for vector-based retrieval. Once those indexes have been generated, they're all stored in our AI search service. Now let's look at this from a user query perspective. As a user issues a query on your agent, the agent will reason over the available knowledge and query out to the files that's detected here. As part of that, Copilot Studio may rewrite that query and provide additional context in that request. As we receive that request, we're going to augment that request further, identifying the specifics that are required, classifying that request, and then best executing the query against the search service. Our search service will return back the most appropriate chunks, and then we will then further process those chunks, identifying what is going to be the most relevant for that customer's answer, respond appropriately to the agent, and in turn your agent will respond to your user. Now let's take a look at how Dataverse uses knowledge. Dataverse fundamentally is going to translate that user query into a runtime query we can then execute against those tables. As a maker, you will go through the configuration process of selecting tables, adding them to your agent. And when you do so, there's the optional ability to provide synonyms and glossary. These are there to enable you to add additional, more nuanced understanding for your data. This is really you trying to help your agent understand some of the more bespoke and business domain requirements of your data. Now, once that table has been added to your agent, we'll index that table in two different approaches. Indexing the data from the tabular perspective, but also from semantic perspective. Here, that semantic index is used to generate a deeper understanding. You can imagine things like abbreviations. WA here actually would refer to Washington. Now let's look at this in action. As we take an example here, this user's query, get Adriana's closed orders in WA, as we know as Washington, has been issued against your agent. Again, similar to files, Copilot Studio will potentially add additional context to that query, providing context from the previous conversation and potentially any engagements there. Hand that over to Dataverse. At this point, we're going to do some annotation, detecting key values in that query, Adriana and WA. We're going to combine those annotations along with any synonyms and glossaries that were provided as part of that table configuration. Here, we'll use that information to scope down the query, identifying the key tables and columns that we need to map against in the schema. Once we've identified those columns and tables, we'll hand that information to an LLM to generate SQL, fundamentally transpiling that to fetch XML and executing it against the tables. Once that execution has happened, we'll receive the summarized results, pass that back over to the agent, and in turn, your agent will answer the question. So here we'll look at a demo. We'll walk through an extension of the scenario that we were looking at earlier. We had the e-commerce product review case. Now, from our perspective, we're going to be building out a conversational agent that can assist with our employees. Our employees are working to process returns as part of our business. Now, as they process those returns, they may run into issues where they need clarification. They need additional understanding before they can make a decision on how to handle that request. Let's look at how files and Dataverse's knowledge in that conversational agent could assist with that. So let's take a look at our conversational agent here. We've built out an agent which is going to assist in handling returns and particularly assist in handling an understanding of those returns and the policies behind them. Here I have a very light description and some minor instructions to this agent. This agent has already been provided with 3 PDFs and a selection of different tables for its knowledge. Those PDFs are really just a combination of different content from a text perspective and some process perspective, but really outlining what is the policy requirements for returns, how should that process work as an employee within this business, and then some exceptions to those rules. Our agent doesn't really have any special configuration outside of that, but as you can see, it doesn't actually have access to do anything other than make use of this knowledge. Now, let's take a look at the scenario. Here I'm an employee. I've predominantly been working in an alternative app, processing my return requests. But I've hit a more unusual issue. I've received a request, and this request is actually marked final sale. I don't know how to handle that. So let me engage with my agent. Here I'm going to ask, what is the return policy for final sale items? At this point, our agent is going to look over its knowledge sources, determine which of those knowledge sources are the best to reason over, issue the query out as we saw earlier. In this case, it's going to reason over the files. The files are then going to come back with the appropriate set of chunks that this then agent can summarize and return an answer back to me. And we can see here, final sale items are actually eligible for return, but there's a caveat. There's a restocking fee of 50%, which will be deducted from the refund. There's also a call out here to ensure that the customer understands these conditions. That's great. Well, let's understand what is that refund. So here I'm going to ask, what is the total amount for that order? And let's calculate the refund. At this point in time, our agent is going to have to reason over a different set of knowledge. It's going to have to query out over that tabular data. Here, it's correctly returned that the order associated with the return request has a total amount of $239.95. Knowing that there's a 50% restocking fee, our agent has actually calculated, combining the structured knowledge with the contextual knowledge of this previous conversation, calculating out that we're only going to get 50% on that return. That's great. Why I'm here, I'm going to just understand what was the actual reason for this return in the first place. Now, again, our agent is going to have to query out against those knowledge sources. But in this instance, it's actually going to query out over a multi-line column. This is something which is unstructured data in the structured context. That allows our customers to submit paragraphs of information if they wish for their reasons, but it also gives us the ability to understand more specifically what they're actually returning for. Our agent here successfully returned back the reason and appropriately stated that this wasn't any kind of problem with the product that just didn't deliver on time. That's great. Now, we can stop here. I can potentially go back to my app as an employee and continue the process. But what if I could do more? So let's take a look at functions. Functions allow us to extend our agents with actions, particularly allowing us to reuse business logic across both our apps and our agents. Let's see how to configure that. So here I have functions inside of the Maker portal. I can easily come in and create a new function, setting up the inputs and outputs and the respective tables and logic that it's going to operate over. But rather than doing one right now, let's take a look at one I made earlier. Here we have the approve return request. It has 3 different parameters and 2 outputs. It's referencing 2 different tables here with rather complex business logic here, doing some checks and making some things in order. Let's see how we can apply this function to our agent. We can add an action, go into the Dataverse connector, and choose the unbounded action Here I can go through selecting the environment, name of my action, and configuring the appropriate inputs and outputs. But rather than doing that right now, let's make use of the one that's already there. In this action, you'll see that this contract mirrors directly to the function we just looked at. So you can see here we have the same inputs with a couple additional inputs here defining the environment and the action that we actually want to run. Here, those inputs, rather than being statically defined, are dynamically available for the agent to make use of. In order to assist the agent, I provided a minor description with each of these inputs in order to help it find the right parameters to populate. Now let's try this. Continuing exactly where we left off, the conversation we ended was we had our final sales scenario. We understood that it is eligible for return. We've calculated the refund appropriately and verified that the request for the return was valid. Well, that looks good to me. Let's approve it. And as we looked at that schema earlier, we know our function is going to expect 3 inputs. One of being the return request ID, another being the associated order ID. This is part of the business logic that's configured in that function to do some double checking and just verification there. Here, I'm going to provide that up front. Now, as I mentioned, there was 3 inputs, but I've only provided 2. At this point, our agent is going to try to infer from that prompt what is the next best action to take. And here, we can see that it's detected it should approve the return request. It's appropriately populated the inputs it could, and then prompted me as a user to fill in the rest. As you can see here, it's asking what is the reason for approving the return request. Well, for this, it's final sale, and it meets our policy requirements. I can now submit that. The agent here is actually going to continue on that action that it's paused, executing that task and that function over our data and appropriately updating the return request as approved, indicating what the refund will be and giving me the next steps of notifying the customer if it's necessary. As we just seen, functions empower your agents to do more by encapsulating business logic for reusability across both your agents and your apps. Speaking of empowering your agents to do more, what if they could operate independently?
By now, you're probably asking, what are the fundamental ingredients to a team of autonomous agents and humans in a business workflow? First, AI agent operates autonomously where end users can review and correct the agent's output. And end users get insights or details from the workflow. This means that agents and humans are working both on operational data, business data, and typically there's some kind of app for human interaction with this data. A great example that illustrates the team of agents and human working together is the document processor template. This template creates one autonomous agent that processes invoice files received via email and stores these invoices as business data into Dataverse. It also logs the agent state machine operational data in Dataverse. The template also creates a monitoring app for humans to review agent operational data. And it will also create a Canvas app for humans to review the business data, which is invoices in this case. In this demo, I'm going to start with showing you the doc processor agent, then the monitoring app, followed by the invoice app. The autonomous agent here has its logic described in instructions with triggers pre-configured to act upon email received. Now let's switch to the monitoring app to see what the agent has processed. The agent has processed one invoice and scraped the relevant details from this PDF file to the invoice table. Now let's give it the test from end to end, starting with sending an invoice to set off the trigger for the autonomous agent. Here we can see that a new invoice has just arrived and been processed, and it has status updated to manual review. This is where the agent is flagging the human intervention is needed. The agent notifies human via email to approve, reject, or correct the details. From this app, human can see the error and make the required change. In this particular instance, the issue happens to be date formatting. So let's correct that, and Let's approve these. Now, the autonomous agent then can continue the workflow. It updates for manual review to validate it, then export it as the final success state. Under the hood from the Maker portal, we can see both business data and operational data stored in Dataverse. Now that we've seen a simple demo, let's see this in action with stories from two leading AI companies, Velrada and 𝗦𝗲𝗀𝗀𝗀. Their solutions will illustrate how teams of agents and humans can seamlessly work together using Copilot Studio, Dataverse, and the Microsoft ecosystem.
Hi there, everyone. My name is Samuel Smith, and it's my pleasure to give you a demonstration of ShiftLens. So, managing last-minute scheduling changes, which are often caused by unplanned absences, can really significantly impact teams, draining valuable time as team leaders scramble to find replacements with the right skills and availability. So to tackle this challenge, Velrada introduces ShiftLens, which is a set of autonomous agents and workflows powered by Microsoft's Copilot Studio, and is fully integrated with our leading frontline worker solution, PowerRoster. So let's consider an example scenario at the fictitious nursing home, 𝗦𝗲𝗀𝗀𝗀 Nursing Home. So Caroline, who is the on-call team lead, is in the middle of a demanding shift, busy attending to patients when suddenly Sam emails her about her sudden illness. Now, instead of Caroline needing to step away from patient care to deal with this urgent scheduling issue, ShiftLens then steps in automatically. It leverages autonomous workflows and recognizes and analyzes Sam's message. So it extracts the key details from his email about his absence, and then immediately logs the information directly into Microsoft Dataverse. The autonomous agent then proactively responds to Sam, ensuring he's informed about the organization's sick leave and return to work policies by referencing knowledge sources configured directly in Copilot Studio. So without any manual intervention and guided entirely by natural language, ShiftLens updates the roster with Sam's absence, along with a recorded summary. So next, ShiftLens autonomously identifies suitable replacements who are available and possess the required skills to cover Sam's shifts. Caroline then promptly receives an automated approval request, notifying her Sam is unavailable and recommending Matt as a replacement. Caroline can quickly review the recommendation and confirms Matt's suitability by approving the request with just a single click. Immediately upon approval, Matt will then receive an SMS notification from PowerRoster detailing the new shifts offered. He can then confirm his acceptance, and in seconds the roster updates automatically, keeping Caroline fully informed of that successful schedule adjustment. So, thanks to autonomous agents and intelligent workflows from Copilot Studio, 𝗦𝗲𝗀𝗀𝗀 Nursing Home can now significantly reduce manual scheduling efforts. It's going to enable care workers and team leaders like Caroline to spend more of their valuable time focused on delivering exceptional patient care.
That was such an amazing and powerful story. Thank you, Velrada. Now let's move on to 𝗦𝗲𝗀𝗀𝗀𝗀.
Hi, I'm 𝗦𝗽𝗲𝗀𝗀𝗀𝗀, Global Head of Product Innovation at 𝗦𝗲𝗀𝗀𝗀, the global legal ISV. Today, I will show you our innovative solution that assists law firms in managing court document instructions through the collaboration of autonomous agents and lawyers. This solution aims to minimize the risk and reduce mundane repetitive tasks by leveraging the strengths of agentic agents and legal professionals working together. The legal industry is facing a data explosion. Lawyers and legal teams are overwhelmed by the volume of court documents, emails, and critical information flowing into their systems every single day. With this complexity comes risk, manual effort, and lost productivity. To manage this, operations are becoming harder than ever. Court emails arrive with critical information buried deep within their attachments. Manual processes dominate the way it is then captured, reviewed, and then followed up and actioned from. How we solve this is by building an autonomous agent that is monitoring the inbox of the lawyer and looking for court-related documents to act upon. It then takes this information and automatically in the background extracts the content. The information is then passed to the court claim agent that then calculates the dates from the court and then stores them as tasks within Dataverse, This then ensures that a lawyer can collaborate and refine any additional information is accurately recorded. Now let's switch into the Court Claim Assistant. You can see there's some pre-prompts to help you go through, but in this scenario, what I'm going to do is I'm going to ask what the next hearing is. Through all of the hearings in the system, Dataverse is able to facilitate the next hearing that's relevant to me. Additionally, I want to ask about where the address is for that court hearing. So without having to look up on the address, I don't have to go and switch to another application. It'll give me the court address. Now we've just had a court document has been added. So this is the autonomous agent has come in and facilitated a prompt to say that it's just processed something to be reviewed. At this point, I can summarize this claim. And what it's now going to do is use Dataverse and the information that's been extracted to summarize that in a really simple way without me having to switch context yet again, providing that really rich, deep experience for all of my lawyers to be able to facilitate one common place for the court claim management toolset. At this point, I can ask any tasks that are relevant for me to complete. It's again looking at the task list. It's been able to use that Dataverse connector using knowledge inside of Copilot Studio to facilitate that next step. All of this is available for all of my lawyers to use with a focused agentic flow, managing all of my user experience around the management of court claims. Let's take a look at how we went about creating these intelligent apps. The first agentic solution that we take was a trigger-based solution on an inbox. Basically, the rules behind the inbox was looking for an attachment, but more complexity could be taken and additional steps could be taken to further validate the type of document. But in this scenario, what we did is we looked inside of the document and looked for attachments. Once it found an attachment, it was then able to provide that as a process to run through a number of steps that then was enabled then to using Copilot to give a prompt to take the information from that content and extract it appropriately into something that was then a JSON payload for future use. Under the Actions tab, we then took that information and we've got one task as an example here to create tasks from the JSON payload. What this does is it takes the actionable steps that's come from the Copilot Studio usage of agentic AI and then facilitated that into something that was then taking that information, extracting that, and then creating the appropriate records inside of Dataverse, ready for that human-in-the-loop process to review that inside of Dataverse naturally. Let's talk a little bit about our agents and how we built them. The Court Claim Assistant, that is a Teams-based agent, is also agentically working. It's monitoring various things going on in the background. So we give it a general language instruction, but then we start to tie it to knowledge. The court form information that's been stored inside of Dataverse is now a rich pickings of information that could help complement the agent and the service as to how it sits within inside of Teams. At this point, we can give some starter prompts to help you induce the conversation, and also to share the ability of what the capability the agent supports. We then create a trigger that's coming off Power Automate to start the journey and the conversation. So what this is basically doing is it's looking at Dataverse and taking an addition to a row inside of one of the Dataverse tables, and then it provides a number of things. And that step is a very simple process of, is this a new form? If it's a new form, I want to post a card in a chat into Teams to explain and undertake a little bit of a declarative agent here to then respond based on that information directly inside of the Teams channel. This, together with the starter prompts, provides the foundation as to how you're going to build out the information. But equally, you can test that agent inside of your Copilot Studio facility, and you can understand how it's going through the flow and understanding that success, and then building out on that journey. So the whole life cycle of how you can build these solutions and then publish them are all available to you. This agentic solution has been powered by Copilot Studio to build our autonomous agent, with a notice of court claims agent and our interactive chat agent working together as a claims assistant. We then use the model-driven Power App to display and capture the interactions between end users and agents. And finally, Dataverse as the underlying data platform to store the business data such as claims details and the operational data of our autonomous agent.
That was inspirational.
Yeah, what great examples of autonomous agents. Thank you both, 𝗦𝗲𝗀 and Velrada.
All right, we have covered a lot of ground today. To recap, Dataverse is your trusted data platform in the AI era. It allows you to apply generative AI to your existing data and store operational data alongside it. Today, we showcased several key features: improvements in Dataverse knowledge and file knowledge in Copilot Studio, Plan Designer to design your data model in Dataverse, Data Exploration Agent, which helps you to filter and visualize in natural language, invoking reusable functions inside your agents to automate a business process in Copilot Studio, prompt columns, document processor template in Copilot Studio to illustrate teams of human and agents working together. Also, coming soon is Dataverse as MCP server, and you can learn more about this here at Build 2.
To learn more about how you can get started, please see the available links. Thank you for tuning in today and have an amazing build. We look forward to not only seeing, but hearing about the great agentic scenarios that you come up with. Thanks again.
See you next time.